Hello students, today our topic is work done in a conservative field. Our earth which has a gravitational field, this field is also conservative field. Now what is a conservative field? Conservative field is a field in which the work done by the force of gravity. In this case we are taking the gravity example. By the force of gravity is independent of the path followed by the body. For example, if this body is brought from here to here, and this then from B to C, then in moving the body from A to B, then B to C, the work done by the force of gravity we noted, and again we move body from A to C, and this work in moving the body from A to C is exactly the same as the work done in moving the body from A to B and then B to C. It means that the work done by the force of gravity now is not depend on the path followed by the body, but only depends on the initial and final positions of the body, which is the same in both the cases. And other is the total work done by the force of gravity in moving a body in a closed path is zero. For example, uh, body is moved from C to B, and then B to A, and then A to C. Then in moving the body from C to B, then B to A, and again A to C, the total work done by the force of gravity is equal to zero. If it were not the case that the total work done by the force of gravity is equal to zero, then it would be possible for us to utilize this useful work to run. For example, this useful work can be utilized in running an electrical generator. But as we know, it is not possible, therefore, it is not possible for us to make a machine which is working continuously in a earth gravitational field on the expense of the force of gravitational field energy. Let us take first case. The body is moved from A to B. In this case, then from B to C. Okay. When the body is moved from A to B, we know that the force of gravity, which is acting on the body, and the displacement which is being covered in moving the body from A to B, both are in the same direction. Therefore, cos is equal to 0, and we know that this force of gravity is equal to mg, and work done in moving the body from A to B becomes mg d1. Again, now the body is moved from B to C. Now the force of gravity in this direction, and the displacement which is being covered is along the BC. As the angle between these two is 90 degree, and we know that the cos 90 is equal to 0. Therefore, work done in moving the body from B to C is equal to Fg, which is the force of gravity, dot displacement vector d2. The angle between it is a dot or a scalar product. Therefore, this formula comes out cos 90 is equal to 0, and the work done in moving the body from B to C is equal to 0. Now we direct move the body from A to C. Now the force of gravity, and that's the weight of the body of mass m, and the displacement which is being covered is the d. The angle between these two vector is theta. Actually, the ABC is the right angle triangle, and we can prove that when these two lines AB and this this the vector weight of the body are parallel to each other, then these two angles will be equal to each other. Okay. Now we apply the formula, the work done in moving the body from A to C. Again, the angle between these two vectors is equal to theta, and our weight is equal to mg, and our final formula comes out mg d cos theta. Uh, triangle ABC is a right angle triangle. Therefore, cos theta is equal to the adjacent side, which is adjacent side angle, and divided by the hypotenuse. Therefore, d1 is equal to, now we will again write the formula. Work done moving the body from A to C is equal to mg d cos theta, and we have already seen that d cos theta is equal to uh, d1. Okay, now we can see that this work done in moving the body from A to C, and here the total work done in moving the body from A to B and then B to C comes out, the mg, both works are equal. It means the work done in moving the body from A to C is independent of the path followed. It is only depend on the initial and final position, or initial or final point, which these 2 points are the same in both the cases. Now let us take the second case, in which the body is moved from A to C, then C to B, and finally it is brought to A from point B. Is brought from point B to point A. In moving the body from A to C, F is the force of again gravity, and this force of gravity is the actually weight which we already actually it is calculated. Actually, there is no need again doing the same calculation. Okay. Now the body is moved from C to B. But in moving the body from C to B, we will not calculate the work which is being done by the external agent, or the work which we are doing in moving the body from C to B. But we are calculating the work which is being done by the force of gravity in moving the body from C to B. Okay. Now, in moving the body from C to B, again we have already calculated that now the displacement vector d2 is in this direction, C to B. Angle is 90 degree, and again this works in moving the body from C to B by the force of gravity comes out 0. Otherwise, we must, student, it should be clear to you that the work done in moving the body by external agent is C to B is not 0, but we are calculating the work done by the force of gravity, which is equal to 0. Now this body is moved from B to A. In this case, as we are moving the body from in the upward direction, and the force of gravity or the weight of the body is in the downward direction, an angle between 180 degree, where you know that the angle is 180 degree, cos 180 is equal to -1. Therefore, the work done in moving the body from B to A by the force of gravity comes out negative, minus mg d1. But student, you must understand, or must keep this thing in your mind, that the force which we are applying on in the upward direction, moving the body from B to C, must be equal to this force of gravity, so that the total force so that the resultant force on the body is equal to 0, and it should not increase the velocity of the body, and the body should be moved from B to C with a constant velocity. So the work done by an external agent in moving the body from B to A should only increase the potential energy, but not the kinetic energy of the body. Okay. Now we calculate the total work in moving the body from A to B, A to C, C to B, and again B to A by the Earth gravitational field, which is equal to, this value is equal to mg, work C is equal to 0 and minus. So the total work done in a closed path is equal to 0. Other examples of conservative fields are magnetic field, electric field. These are the field in which the total work done in moving a body around a closed path by the electric field or the magnetic field will also be equal to 0, and the same case as it was in the Earth gravitational field, that the work done in moving the body from one point to another point will be independent of the path followed, but only on the initial and final points. Okay, friction force, which is a velocity dependent. You know that the force of friction is not constant, but it increases with the velocity. Therefore, it is not a conservative field. Conservative. So you must remember that velocity dependent forces are not the conservative forces like force of friction. Okay, thanks.